All right, so now we're at the second section, or the second type of partial fractions, or, well, yeah, let's say second type of partial fraction. So here, this is where we have proper fraction with repeat linear factors. This says the denominator of the proper fraction contain repeated linear factors of the form cx plus d to the nth power. For each repeated n times, there is a corresponding sum of n factors of the form whatever, lambda 1 over cx plus d plus lambda 2 over cx plus d square plus lambda 3 over cx plus d cube plus lambda n over cx plus d to the nth power, where lambda 1, lambda 2, lambda 3, and lambda n are constants to be found. For example, p of x over ax plus b into cx plus d all square would be equal to a over ax plus b plus b over cx plus d plus c over cx plus d square. All right. So note the sum of two fractions associated with the repeat linear factors, whatever that means. All right, I'm going around and I'm going to do example 5. Example 5 says separate 2x plus 1 into partial fractions. 2x plus 1 over x plus 2 into x plus 1 square into partial fractions. So what we have, let me look at the ink. I'm changing the ink back to red. We have 2x plus 1 over x plus 2 and our repeat linear factor, which is x plus 1 squared. So when I separate this, I'm going to have a over x plus 2 plus b over x plus 1 plus c over x plus 1 squared. Now, if it was cube, you would have a over x plus 2 plus b over x plus 1 plus c over x plus 1 square plus d over x plus 1 cube. That is if it was cube, but it isn't cube, it's square. All right, so I'm going to get rid of the fractions by multiplying everything by the denominator over the left-hand side. I'm going to multiply the entire equation by the denominator on the left-hand side. So I'm going to end up with 2x plus 1. And this is equal to a into x plus 1 square. Or if I want, I could say x plus 1 times x plus 1. I don't think it matters. Plus b into x plus 1, x plus 2, plus c into x plus 2. All right, I need to find out what is a, what is b, and what is c. Let's get rid of b and c by saying when x is minus 2. I'm going to say when x is equal to minus 2. I'm going to have 2.
Excuse me, sir.
Go ahead.
Sir, shouldn't c be over x plus 1? Should it be x plus 1 squared?
Yes, it should be x plus 1 squared.
Okay, sir.
All right. So this is 2 into minus 2 plus 1. And this is equal to, remember when x is 2, b and c goes. I'm going to have a into 2, minus 2, sorry, plus 1 square. Minus 2 plus 1 is minus 1. Minus 1 square is 1. 1 times A is A, so A is equal to minus 4 plus 1. So A is equal to minus 3. A is minus 3. Let us get rid of let's get rid of A and B by letting X be equal to minus 1. I'm going to say when X is equal to minus 1, I'm going to have on the left 2 into minus 1 plus 1 is equal to, when X is minus 1, A goes and B goes. So I'm going to have C minus 1 plus 2. Minus 1 plus 2 is 1. 1 times C is C, and this would be equal to minus 2 plus 1. Minus 2 plus 1 is minus 1, so C is minus 1. So I have A and C. What I need now is B. I have A and C. What I need now is B. Now to find B, I'm going to equate the x squared coefficient. To find B, I'm going to equate the x squared coefficient. I'm going to say A plus B, and A and B are the x squared coefficient on the right, is equal to the x squared coefficient on the left, which is 0. So I'm equating the x squared coefficient. There's no term in x squared on the left, so the x squared coefficient on the left is 0. Therefore, B would be equal to minus A. So B would be equal to minus whatever A is, which is minus 3. And negative times a negative is a positive. B is equal to 3. So therefore, what I have, 2x plus 1 into x plus 2 into x plus 1 squared is equal to A, which is minus 3 over x plus 2 plus B, which is 3 over x plus 1 plus C, which is 3, C is minus 1. So let's put minus 1 over x plus 1 squared. And that would be our final answer.